my vlog. As to why I didn't make it Saturday or Sunday, don't really have a reason, just didn't get around to it. Monday, I made most of it, which is why you'll see me in a different t-shirt, but I had issue with the video editing software, it didn't produce right for whatever reason. As for last week, I didn't make it partly because I was studying for finals, but the main reason is I was working on a Minecraft adding machine. Now this is a terrific way for me to explain both how an adding machine works, and to show off the one I made in Minecraft. Now unfortunately, my capture card only works on the Xbox, because you need like software to report on the computer, and it's just different systems, so I can only really show you screenshots of it, so unfortunately no moving pictures. But I'll try and do the best I can with that. Now, an adding machine works by using a series of logic gates, and logic gates work by sending or not sending a signal based on whether or not it is receiving or not receiving a signal or signals. Now, this logic gate is an AND logic gate, and as you may be able to see, it is 3, in my case, dirt blocks, but it can be any block really. 3 blocks kind of along in a row, with then 2 redstone torches, one on the top of each end block, then 1 piece of redstone dust on top of the middle block, and then a redstone torch on either side of the center block. Now this works by if power is being sent to both end redstone torches, this is the input, then they will not transmit power. Because in Minecraft, whenever a redstone torch is sent power, it will not send power itself. So if power is being sent to both redstone torches, they will not transmit power along the center redstone dust piece to the center redstone torch, which is the output in this logic gate. So if power is being sent to both redstone torches, they will not send power to the center redstone torch, and that will then send power. So this is generally how a logic gate works. If power is being sent to both inputs, the output will also send power. It will not work if power is only being sent to one input. For an OR gate or a extender piece, they both follow the same design structure. We have 2, in my case, dirt blocks, but again, it can be whatever, but 2 blocks lined up, and then on top of one of them, we have a redstone torch. On top of the other, we have a redstone dust piece, and then on the same block with the redstone dust piece, we have a torch on the side away from the redstone torch. For the OR gate, we have that if power sent from 2 different locations is sent to the block with the redstone torch on top, that's the output by the way, then the redstone torch will be deactivated, and it will not send power along the redstone dust piece to the other redstone torch, the one on the side of the block. And if that power is not sent to that torch, then that will send power. This is the output then. Now, mine looks different. It appears to only have 1 input, but it actually has 2. It does have the 2. It's just 2 switches connected to 1 redstone path, which is connected to that block with the redstone torch on top. And this is fine to do, as long as at the base of the path you do have 2 inputs, like I do. But back to the OR gate itself, this is generally how OR gates work. It has 2 input areas, and as long as one, doesn't necessarily have to be both, is sending power, then the output will send power. Now, for the extender piece, this is simpler than the OR gate, because it only has 1 input, but otherwise it works in generally the same manner, where that if power is being sent along that input, it will deactivate the redstone torch that's on top of the block, and thus the redstone torch on the side of the block will be activated because power is being sent to that, and thus it will send power along the output. Now, the reason I have this is because redstone dust can only send power 15 blocks, and so if I want to send it more than 15 blocks, I need to put that in. And normal adding machines don't have this because they don't really have a limit to how long power can be sent along a wire. Now, finally, we have the simplest of the logic gates in an adding machine, the NOT gate. Now this is simply just a block of whatever, in my case dirt, with a redstone torch on one side. Now, a NOT gate works simply by, if power is being sent to the block, this being the input, then the redstone torch will be deactivated, and thus that won't send power along the output. And this is used in adding machines to reverse power. It works pretty much in the same way that if power is being sent to the input, then the output will not send power. Now, an adding machine works by adding numbers in binary. And if you didn't already know, binary is a number system in base 2. Now, we use a number system in base 10. Now, our number system works that one place can only hold up to 9 digits, and when we get to the 10th digit, it has to carry over to the next place, which would look as 1, 0, which we read as 10. Now, for binary, one place can only hold up to 1 digit, and when we get to the second digit, it has to carry it over to the next place. So this would work by if we have 1, that would just simply be 1. Well, if we have 2, that would be 1, 0, because it had to carry the digit over to the next place. While 3 would be 1, 1, adding the 2 and the 1 together to get 3. Now, that's the unfortunate thing with binary, because for the adding machine, you do have to convert the binary to base 10, so you do have to do a bit of math with it. Now, an adding machine is comprised of a series of half adders, and there are more than 2, which is just the name of it. But for an adding machine, we have the 2 switches, each one representing a different place for the 2 different numbers. Now, in this case, given that we only have 1 half adder, these are both for the 1's place. So, if the switch is off, that represents a 0, while if it's on, that represents a 1. So, say one of the switches is on, that way the AND gate will not be able to be on, because both switches are not sending power. However, the OR gate will be on, and that'll send power to the other AND gate, which, because of the NOT gate, will have power from the other way, and thus that'll send power, representing a 1. While if the other switch is also turned on, then that, the first AND gate will be on, and it'll send power to the NOT gate, which will disable the second AND gate, and thus a 1 will not be represented. However, we will have it where it carries a digit, just after the AND gate, but before the NOT gate, and that will represent the 2. Adding machines are categorized by bits, and a bit is determined by how many places the added numbers can go up to. For example, a 1-bit adding machine adds numbers that are only in the 1's place, while a 2-bit adding machine adds numbers that can go up to the 2nd place. And this determines how powerful an adding machine is, because the more bits an adding machine can add together, the larger the numbers the adding machine can add together. Also, for the answer, you will need an extra bit in there than the added numbers. For example, if you're adding a 2-bit number, then you'll need a 3-bit answer, because, like, for example, 3 plus 3 gives you 6, and that can only be represented using 3 bits. Now, the adding machine gets much more complicated as you add more bits, because each bit you add, you need to include 2 more half adders, because we have the first half adder, which is just for the 1's place, and we've got the second half adder, which would be for the next place, in this case, the 2nd place, and we also have the third half adder, which will need to combine the standard number from the second half adder and the carry number from the first half adder. Now let me explain this. We've got the first, or the standard number from the first half adder, and that gets carried right around to the first place in the answer. And then we have the carry digit from the first half adder and the standard digit from the second half adder, which are combined into another half adder, because those both take place in the 2nd's place. and then the standard digit from that third half adder is carried to the second place, while the carry digit from the third half adder is carried to the third place, as is the second digit, or the carry digit from the second half adder. So we combine the carry digit of the second half adder and the carry digit of the third half adder with an OR gate, because both of them will not be activated at the same time, just how the machine works. And then those are combined by an OR gate, which is then sent to the third half adder. And it just gets much more confusing as you kind of have to add in more half adders as you increase in bits, and then connect those by OR gates, and then the other half adder. So it just gets confusing as you continue on. Now, in reading my adding machine, if a torch is on, that means it's a 1, while if a torch is off, it means it's a 0, and you read it from top to bottom. And I would recommend installing NOT gates between the final path and the answer, because if it's sending power, that means it's a 1, but if it sends power to the torch will be deactivated. And so I just think it looks better with the torch being on, meaning that it's a 1. I mean, you can't have it the other way, but I prefer it with the NOT gates. But yeah, so that's how an adding machine works. I tried to explain it the best I could. Hope you guys understood it. So far, I've made my adding machine up to a 4-bit, but I just hope you guys enjoyed it.